Kepler's third law, also known as the law of periods, states that the squares of the orbital periods of the planets are in the same ratio as the cubes of the semi-major axes. Let us first assume that a planet's orbit around the Sun is circular. Then its orbital period corresponds to the circumference of the orbit divided by its velocity. For two planets with different orbital radii, the ratio of their orbital periods behaves as follows. This yields the following equation. A comparison with Kepler's laws shows, if the planetary orbits are circular, then Kepler's third law is perfectly correct. But does it also hold for non-circular orbits? Since Kepler's law is based on the assumption that the planetary orbits are elliptical, we will now verify the validity of Kepler's third law using elliptical orbits. There is no exact formula for the circumference of an ellipse. It is usually expressed by the following approximate formula. So if the semi-major axis is equal to the semi-minor axis, the shape is a circle, and its circumference is. If the semi-minor axis is 0, i.e., the ellipse is a straight line, its circumference is 4a. If the semi-minor axis changes from a to 0, its circumference changes from 2 pi to 4a. This means that ellipses of different shapes each have different circumferences. This means that Kepler's third law applies only to planets whose orbits are similar ellipses. In reality, however, the orbits of all planets are different. Therefore, Kepler's third law is false.